for the invitation to come and present on a topic that I've been workshopping for over a year, actually almost closer to 2 years. And I'm excited to be here. I'm actually excited to have an audience to listen. So please bear with me. It's going to be hopefully an enjoyable ride, an informative, enjoyable ride. So the outline, I wanted to give you kind of an outline of this presentation. So I'm going to do a quick introduction of 3 sites in particular that kind of started this ball rolling, which then led me to a series of inspirational events at a time when I really needed it. And then kind of discussing working with large radiocarbon data sets and implications of the risks and implications of actually doing it. And then modeling that data with OxCal, and then doing regional modeling and trends. So tonight's story begins with the Starr County site 462. And to kind of give you an idea, it is really close to where the TAS annual meeting is going to be. It's just outside of McAllen. This site is just north of Rio Grande City on a drainage called Arroyo Los Olmos. This is a site we discovered years ago, 2017, on a TxDOT project for a new roadway with Chris Ringstaff. It is located in a very broad valley for that area, and it's just a couple of miles upstream from the Rio Grande. And I'll be rushing kind of through this because there's a lot of ground I want to cover, so apologies. Before we even started the survey, we had a suspicion that this would be a pretty prime location. Hester and colleagues back in the 70s pointed out that this drainage in particular had a majority of the sites in the region at that time. And it still does, to my knowledge. This blue box is roughly, This blue box, that's site 462. So I actually got on the ground, or we got on the ground in 2017 and actually did some trenching. I actually got to see the drainage itself. And to me, I was very excited. This is a lot of alluvium for that part of the state, not on the Rio Grande. And the fact that there was so much alluvium on a pretty decently broad floodplain in an area that was known to have a lot of sites, I was really excited. And then just walking around, this is before we even started trenching, you see firecrack rock and chert artifacts and tools just eroding out about everywhere you go. So it was like, we knew we were in a really nice spot. And sure enough, that survey in 2017, 2018, we did find stratified deposits, which I'm skipping a lot, but that did lead to a data recovery, which we completed over a year ago. And we just submitted the final report of those excavations. And I did want to kind of show you some of the cultural stuff. There is not going to be a lot of artifacts in this presentation tonight. There's not going to be a lot of features. We're going to be kind of talking about some of the data that we get from some of those features. So these are some of I think we had over a dozen thermal features. And keep in mind, this is stratified deposits. So these are three examples of what we were seeing. And then for cultural materials, some of the artifacts, it's kind of the standard toolkit we're seeing in that part of the state. We have some archaic to late prehistoric. So there's a lot of hidalgos and Tortugas and Matamoros. And then I did want to include this image. That photo does not do it justice. That is a knife, what we're calling a knife, made out of petrified palm wood. And when you see it in the light, it's just absolutely beautiful. It was one of those, like, I'd never seen anything like it, especially that complete. It was really gorgeous. The stratigraphy of this particular site was, we basically had Holocene alluvium, the entire Holocene, all the way to the late Pleistocene. And then we're able to date it. Brittany Gregory and I put in a lot of dates. And so we were able to get all the way into late Pleistocene, all the way to the Holocene. So we have the entire Holocene alluvial picture there. There was no disconformities. in this area, and we are on this site, and still can't quite figure this out. Anyway, I'm gonna use the mouse. And then in the upper 2.5 meters, almost 3 meters, we just had stratified cultural features. So it was a gradual, slow deposition. There wasn't like big, huge alluvium to kind of separate these by a lot. So they were pretty tightly packed in a short period, or in a period of time. They were it wasn't quite a palimpsest, but it was stratified cultural deposits that we could suss out. But basically we had quite a few cultural features. There was actually a lot of lithic reduction loci that we were able to identify. So really nice site. And then for the radiocarbon, when I was modeling it, there's clearly 3 different radiocarbon for the features. And these are all from charcoal, from just the cultural features. The radiocarbon itself indicates at least 3, possibly 4 separate occupations. But the thing that caught my eye at the time were these big gaps. So we have kind of a continuous sequence of alluvium, gradual, but it's there. And it's clearly a hot spot for, a prime spot for habitation in the region. And then why were this big, like 1,000-year gap or more between a couple of these occupations? And the weird thing is these gaps kind of reminded me of some other Starr County sites that we had done some data recoveries on previously. Specifically, Starr County 242 and Starr County 459. So these are sites we found for the same TxDOT project years before, and had done the survey, and then eventually came back and completed the data recovery excavations. And then you'll notice these are also in valleys similar to Arroyo Los Olmos, and they're also roughly about 2 miles upstream from the Rio Grande. So 242, which was the site in the middle, that one had pretty much continuous occupation from 4,000 to the present, at least according to the radiocarbon data. We did have artifacts on all 3 of these sites that preceded where the radiocarbon dates came in. So there is earlier archaic occupations on these sites, but they're just not represented in the features. Or we couldn't find anything to date on it. So 242 had that exact same gap in the dates of the cultural features. 459, although they didn't have any features before that, we did have artifacts before it. So it also, none of the dates happened until after that gap. So it was one of those weird, like, is this a thing or not? It was one of those, I got to model it and then kind of think about it for a bit. And then, what is going on with these gaps? Are these a real or artificial thing? Am I kind of making up patterns? But if it is real, how prevalent is it? And what could it represent? And this is at this point where I'll make a slight note of distinction between descriptive versus analytical approaches. So I have a lot of colleagues and coworkers. I've suffered many years of eye rolls and exasperated groans listening to some of my thoughts and everything. And I benefit from those hesitant acceptance and the patience of listening to me talk about some of this stuff. But I am, however, blessed with a lot of friends, a lot of mentors who have encouraged me, and by their example, to have pushed these things all into this analytical approach. So basically the descriptive approach is these just so stories. It's basically, here's the facts, the dragnet, jackweb kind of approach. Just lay it out, write it up, and then it's just so, this is it. There's not much further we can do with it. And if I followed that approach, this presentation would end right now. There's nowhere I could go with it. It's basically, you've seen pretty much, I could give you a little bit more artifact photos. I could give you a little bit more feature descriptions, but I don't like that. I prefer where the fun is in the analytical approach. So that's basically where you take what you know and then you try and explore it a bit and then see if there is some legitimate patterns to it. So if you'll bear with me, I'm going to take you on a little ride. We're going to kick the tires on this and see what you think. And I'm curious what your thoughts are when I'm done. So for a while I pondered it. And like I said, I've been working on this one in particular for over a year, amongst other things. But I put it down for a little bit and I worked on some other projects. And it just kept bothering me, I couldn't, it's like, what can I do with this? How can I test this? And then one weekend I pulled Emily McQuiston's thesis off my bookshelf. It's one I'd had for several years and I'd read sections of it. But that weekend I read it in one sitting pretty much, well, over the weekend. But anyway, I finished it that weekend and it was, I had no idea how incredible it was. Her thesis was basically part of the Ancient Southwest Texas project with Steve Black and the gang. She compiled all the radiocarbon data that had been done up to that date in the Lower Pecos. She conducted a review of those radiocarbon assays and selected only those that were from really specific contexts that were definitively cultural. And then she took those assays that were definitively cultural in good context and then started to model them. She modeled them. Among some of the things she did was she determined the beginning and the end of earth oven usage in the Lower Pecos, the usage of fiber objects in the Lower Pecos, and she also did calculated roughly the estimated population density of the Lower Pecos only using radiocarbon date, rock shelter assays. And that's going to be an important point later in the talk. But most importantly, Emily provided a really incredible detailed methodology of how she did it. And also add as kind of a slight digression, she also has one of the best summaries and explanations of history of radiocarbon and kind of explaining it. It's really straightforward and easy to follow. And I've read a lot of radiocarbon procedures and history and stuff, but I think Emily's is the best. So that reminded me of another article that I had stashed away somewhere. It's an American antiquity article put together by Bob Kelly and colleagues. And you'll recognize quite a few names on this list. A lot of these, Miles Miller and others, had all over a series of several years. In fact, you might even have been contacted by some of them when they were gathering some of these radiocarbon dates. Basically, they compiled a bunch of radiocarbon dates and then organized them and then submitted them to the Canadian Archaeological Radiocarbon Database, or CARD. That article also had a really incredible supplementary materials section. That's one thing I'll note. You always get the supplementary materials in an article because they always seem to come in handy. So those that don't know CARD, it is free. It's an amazing resource. You just got to sign up for it and you can search it. And here's a map of, these are just the locations of when I last checked. I think this is back in May, I'm not sure. But these locations are centroid counties. So you'll notice like in Arizona, it's pretty square. There's pretty but that's basically, those are dates. Each of those counties has dates that are on this database. You have kind of an idea. And what caught my eye is, what are these out here in the middle of nowhere? Those radiocarbons. So I looked, and the one in the Pacific is off the coast of Alaska. That's actually a cave, a dated 8,000-year-old cave. I think they dated a bear. And the other one's on something on a small island. But anyway, you get the idea. There's almost 3,000 radiocarbon dates just from Texas, which is pretty cool. And then to kind of give you an idea, if you've never seen this, I'm assuming you haven't, but here's what it kind of looks like when you zoom in or click on one of those dates or do a search, because you can search by site or location. The cool thing is you not only do you get the results, and it's normalized age, which is important, but it's also kind of a description of what it is and then references. So you can't click on those to go get it, but at least it's a trail to follow to acquire the primary source for those dates. And that's big. That's a huge thing because a lot of these dates you may never even known about. In fact, I didn't even know about this date till I just randomly picked it. And so it's a project that I'm now aware of, and I can go bird dog that down and kind of look into it if I want. But if you're looking for a particular time or a particular location or site name, bison, whatever, you can find it. If it's in there, it can be searched and found. So inspired by all that information and some others, I got really excited and then had an idea what to do to kind of follow through, take that to take the Starr County stuff to the analytical approach. So I started collecting more dates, and I reached out to colleagues and friends, neighbors, anyone who might have had a radiocarbon date down in the Rio Grande Valley, old reports, scans, PDFs, searches, beg, borrow, steal, I got it. In fact, I'm returning two reports to Charles Frederick tomorrow. So yeah, everybody I could think of, I could contact, I got who would have a radiocarbon date on the Rio Grande. So my subject area that I chose was basically the Rio Grande Valley from Hidalgo to Valverde County. I selected those because they have kind of comparable habitats. They've all had decades of professional archaeological investigations. I didn't even spend a lot of time thinking about Cameron and Willacy, which is further downstream. Those are coastal environments. Plus the quick search I did, I could only find I found I think 9 dates. And then I didn't want to have to deal with the marine reservoir effect. I did also explore some of the interior counties along the Rio Grande, Jim Hogg and Brooks counties, but they have almost no dates. So I borrowed Emily's methodology that she laid out so clearly. And to give you kind of a brief breakdown, I only selected dates that had a normalized, conventional, basically corrected radiocarbon age. I only used materials that listed what it was, like what was dated. And I only used assays that had a clear cultural context. So there were assays that were floating charcoal, but they weren't clearly associated with a cultural event or cultural thing. So I would exclude it. And also I excluded the assays that had a standard deviation exceeding 100 years. So it's basically the technology and the process has gotten better. So our standard deviation is more refined. So you'll get radiocarbon at standard deviations of about 30. Those that are 100, that's too far. It really would screw up any modeling that we do, and it just wasn't worth the effort. I'll also note that I excluded all of the rock art dates. I know Karen Steelman and Shumlin, the gang, have done some incredible work, and I'm very excited to see what they're doing. But there's still some disagreement on what is actually being dated. And not that I don't believe that Karen Steelman's dates are bad or in the wrong spot. I just didn't know where the good ones were and the bad ones were. So it's like I don't quite have that knowledge or expertise to kind of select which ones are approvable and which ones are not. But this is something I want to return back to, especially maybe talk to Karen Steelman about it and then pick her brain on what is a good radiocarbon date, or what would be a good sample, which of the samples are good to utilize for an examination. And then ultimately, the other reason I kind of excluded it is a lot of those dates would have kind of already been covered by some of the features that from the sites that they were being found. But again, this is something that I just didn't want to quite have to tackle and then just have that little bit of doubt in the back of my mind. So give you an idea. So this is the counties on the left, obviously, the number of sites that had radiocarbon with cultural affiliation, or that were associated with cultural activity, sorry. The number of recorded sites within the county, and then the percentage of recorded sites that had radiocarbon of that. So, and then the number of the cultural assays from the county that I used, and then the total assays used in the study. So you immediately see there is no radiocarbon in Dimmitt or Kinney counties. And then some of the others not much better. But Starr and Valverde are pretty good. Valverde is really good, and then Webb is incredible. And we can thank my Quig and colleagues in TxDOT for a lot of these dates, because these are a lot of my Quig dates in TxDOT. So it's a big note of thanks to them. The sad thing is, this is only 1%. These dates only account for 1% of the sites in that region. So there's a lot of data missing. So dealing with radiocarbon data set, large radiocarbon data sets such as this, I am inclined, or I'm required to kind of mention, there are some known unknowns. There are some inherent biases that anybody that does this has to recognize and deal with in some way. The first one is, these are the three big, at a minimum, known unknowns. There's the sampling or collection bias. There's the calibration curve bias. And then there's taphonomic or preservation bias, which is, simply put, it's basically the degradation or decomposition or just erosion of a sample that was there, but has slowly just faded away. A good example of sampling bias is Dimmitt and Kinney counties. I mean, I've been on at least 12 sites in each of those counties and recorded them that just never got a date. We just don't, there wasn't anything there to date, or we just didn't do it. There's also the sampling bias of, you may have a site that just doesn't go to testing, data recovery, it gets avoided, and it never gets dated. And then briefly, or the calibration curve, those that don't know it, this is the calibration curve, an approximate of what it looks like through the Holocene. So I'm not going to spend a lot of time on it, but the calibration curve is the approximate curve based on the amount of cosmogenic radiation has kind of changed through time, the solar radiation, and it's affected by the Earth's magnetic poles. So the fluctuations of the radiation coming in has fluctuated, and sometimes it's dramatic, and sometimes, you know, it's kind of steady for many years. And if you've ever had a radiocarbon date, got a result on your radiocarbon date, and you're wondering, why is this got a plus minus of like 300 years? Well, it's probably because it falls on a really bad spot on a calibration curve. And the last 500 years is really bad. You can see, you could have one date that it could be spanned like 200 years. So you don't know where it is, what the actual date is. It's equally possible to be any of those times. And this is where when you're collecting the sample, that the context is really important. So if you have multiple dates and one of those dates is not in the curve, it's in a really good spot, you can at least figure out, okay, you can refine your chronology and just based on your field observations. So anyway, you have to account for this, because the more recent dates, or where those dates fall on the curve, it may give you an error range, a really large range. So it could be over representing that date. And then taphonomic bias, I basically kind of mentioned it. It's the condition, the erosion or decomposition or whatever, the degradation of the sample through time. It just disappears, or we don't see it. Now, to account for the biases, there are researchers for the last few decades have been kind of playing with this. And one of the best ones to deal with the taphonomic bias, which to me is probably the biggest one, it was written by Serval and colleagues back in 2014, or no, 2009. So they basically decided to use kind of a ratio of known geological events that are with a large geographic area. And then kind of develop a formulaic model to account for the anticipated loss of the deposits. And specifically, this is it. So hang in there, it gets worse. No, I'm just joking. I won't even try and break that down. But for us, thankfully, they also propose that if you use a regionally well-dated rock shelter that encompasses the Holocene as a baseline, then you could probably fine-tune your formula. And fortunately for us, Eagle Cave is in Val Verde County, and Halls Cave is not too far away in well, I guess it'd be still southern Texas, but it's not quite. It's in the region, and it's acceptable to me. And both of those have had extensive, not just a group, but several groups over several decades kind of investigating it to really high degree. So these are really good resources, and they just keep giving and giving. And a lot of it is legacy data, but that data is still there, and it's still beneficial if we know how to look for it and how to use it. So accounting for the sampling and calibration curve biases, Williams, he found that in some of his research that if he, for some of his sum probability analysis, that the variability decreased if your sample size was 200 or larger, ideally over 500 samples. So the argument is basically like, yeah, you're going to have some, unknowns, some fuzziness, but the more dates you have, it should statistically come out in a wash, is effectively his argument. So we advocated for a data set of over 500 samples, if you can, and to exclude the most recent 500 years, sorry. And that's to get rid of the calibration curve, or one of the really bad spots of the calibration curve. So it's at this point, I get to talk about some of the ox cow modeling. So hopefully you're all still entertained and excited about it. So this is where I get really excited. So I took that data set. It was, like I said, I forget what my total was, like 536. So we exceeded the 500 that recommended by Williams. I did, however, for my analyses, I did retain the last 500 years. So my modeling does not use Serval's model. That's another model that we'll talk about in a little bit. So this is basically all the dates, over 500 of them, put into Oxcal kind of model. And so I did the sum kernel density estimation. So basically it's kind of comparing all these dates against each other. And then you kind of get an idea of, you may not be able to identify the tune, but at least you can figure out the tempo. So you get kind of an idea of, where things are kind of piling up. And crosses at the bottom, those are the medians. Oh, and I put that orange arrow in there to remind me. So time is basically going backward to the left. So the present is on the right, and then the past is to the left. And then so I've got Hidalgo County at the top, Starr County, Zapata, Maverick, Webb, and then Val Verde. So you get kind of an idea. Each one's kind of color coded, but this is the last 14,000 years, all the dates. So you will immediately notice that there is only a few dates older than 6,000 BP. And then zooming in on the last 6,000, same thing, but it's kind of a close-up. We're kind of only focusing on the last 6,000 years. And then that's my gap right there that I was seeing on 462, and then the other two sites to some degree. So there's only a few dates during that period. This is really cantankerous. There's only a few dates in Webb County. Go back. Use the mouse. There's only a few dates in Webb County and in and in Valverde County during that time. I then took the data and then compared it by setting. So what do the upland dates look like compared to the lowlands? The lowlands are the floodplains and down in the valleys. And then the rock shelter dates. What do the rock shelter look like compared to the floodplain? What do the floodplains look like compared to the uplands? And you can clearly see there is no dates in the uplands, the open air exposed sites in the uplands prior to 5,500 BP, and only a very few that are present in the lowlands. So they were buried and protected. And then only the rock shelter dates really exceed the 6,000 BP for this region. It's just what I was trying to point out with the pointer. 6,000. So here's the last 6,000, same data, kind of a zoom in, give you kind of an idea. And then I overlaid each of those. So the blue is the rock shelters, the what looks like it should be red, but it's orange, the lowlands, and then the orange or the yellow is the uplands. For that period of gap that I was seeing, you're basically, most of them are from rock shelters during that time. There's only a very few that are showing up on the lowlands. And keep in mind that was basically Webb and Valverde County. So very rare. And but most of them that are around are in the rock shelters for that 2,000 to 1,500, give or take. So now we looked at the data a different way. So this is putting the ox-cow modeling, the Bayesian analysis to the side. We then looked at, we then accounted for the taphonomic bias that I mentioned, that fun little ratio that they were talking about, Saravel and colleagues put together. And then on this one, hopefully not to confuse you, time is now running to the right. So the present is on the left, and then time is going backward to the right. So this green line, this is an adjusted for the taphonomic bias, so the degradation through time. And there's a few, only a rare few that are popping up here. These are the ones in the lowlands. But then right around 6,000 BP, it really spikes. There's a big decrease right around 3,500 BP, and then a big spike. And then that black sketch or this dashed line, that's the gap, the hiatus that we were seeing on 462 and the Starr County dates or Starr County sites. So there is a regional decrease in upland, lowland that shows up after it's been accounted, after it's been corrected for taphonomic bias. So laying underneath it, the blue, this is the dates from the rock shelters. So you have kind of like the peaks and valleys. So the higher the spike, the more dates, more presumably activity, cultural activity is going on. And I'll note the rock shelters we did not correct. So these are uncorrected for taphonomic bias. These are as they are compared to the corrected regional dates. So the things that I hadn't noticed before is they're in general, they kind of match, except for the hiatus. So the trends, the increase of the rock shelters kind of match the trends, the increase in the exposed regional sites, except these two spots, the 4,500, where there is a large increase in outdoor lowland, upland sites regionally corrected versus a decrease in the rock shelters. Similarly, at about 2,500 to 3,000, there's the same thing going on. There's an increase outside of the rock shelters and a decrease inside the rock shelters. And I don't know how to account for that. This is one of those, I was unaware of it, and it's something I'm gonna have to circle back to and see what my colleagues, see what they know of it. I'm sure someone's encountered this before. One thing I will note is this period of time where there is between these two big spikes, there's a big decrease in the regional and kind of an uptick in the rock shelters. Solveig Turpin decades ago noted in the Lower Pecos about that time. That was a period of very arid conditions. And she argued at the time that the uplands were being kind of abandoned and everybody was kind of being forced down into the lowlands to be closer to water and by extension, some of the rock shelters. Charles Koenig and colleagues noted about that time as well. There is a large increase in earth oven intensification at that time. So that got me interested in what does the climate, paleoclimate look like for this time for the Holocene. So I pulled out the most recent paleoclimate data that they had done at Hall's Cave. And so you have kind of here they are again. Here's the regional, and then the blue background, that's the rock shelters. So this data from Hall's Cave is based on sedimentation that's come in and then some of the ecological studies that they've done. And it's not just this 2021, but it's over the decades, various researchers who have gone in and examined. So the more recent stuff has kind of put it more into a tighter chronology. So during like 8,000 to 11,000, there's a period of like reduced, it's not arid, but it's like a reduction in general rainfall for the region. And then from like 8,000 to 4,000, there was an overall kind of an increase. In fact, some of the highest rainfall that they had at the time was during this period of time. And then 4,000 to 3,000, there's a 1,000 year period where there was no sedimentation occurring. No sediments were being washed into Hall's Cave, which the inference being that there was almost no rainwater to wash the sediment in. So it was a period of incredible aridity, kind of a drought. And then there were multi-decade droughts at these periods of time. I think it was like 2000, give or take, somewhere in there. But basically, this hiatus, this point, that, and then a decrease in the regional stuff, that's like bingo bullseye for one of the multi-decade droughts, mega droughts is what the authors are calling it. And then one of the other ones is the one at 1,000, and that's, I believe that's the same period of time as a lot of the abandonment of some of the Puebloan groups in the Southwest. And then there's these, and I still don't know how to account for it. I've thought about this. I mean, it's not, I've been working on, I didn't recognize these gaps for a long time. And then it's like, well, wait a minute, what is going on here? This doesn't quite make sense. So again, I'm going to have to, I don't know the answers. I'm just, like I said, we're just kicking the tires on this thing. And if anyone has any ideas, feel free to enlighten me. So one cultural note, talking this through with Brother Ringstaff a while back, we were talking like, okay, what kind of cultural changes are happening at some of these big, peaks, valleys? Is there any big cultural changes? And so I pulled out the Turner et al., the projectile point book, and then because he mentioned we had Tortugas and Matamoros on all three of those sites, and just kind of wanted to see it. And this is solely based on the book, the projectile point book, but the Tortugas, the range that they have kind of identified as 2,000 BP, and then the Matamoros starts up about 1,400 BP. Now, keep in mind, I am making no declarative statements, so there's a big gap there. But talking it through with Chris, it was, in his experience, the ones he's handled, he says there's a clear distinction between the two because the Tortugas almost always have some evidence of asphaltum, or there's no evidence of binding on the lateral margins. So he was thinking it's only been bound or attached to a point with this faultum. Whereas the Matamoros, they all have the binding, and there's no Matamoros binding them up. But I will note that there are sites. Mike Quigg was one of them. He in fact argued it's kind of like a continuation. The Tortugas kind of looks like a continuation of the Matamoros, a refinement of style through time. And I'm not an expert. Basically, I'll leave it to the lithics analysts and professionals to kind of figure that out. Like I said, I'm just looking for things that what was going on at some of these weird inflection points in prehistory. But this is one of those. There's a little meat on this bone. I'm kind of curious what other kind of cultural traits might have been happening that I'm unaware of. So anyway, kind of getting close to the end, kind of a summary of the 500-year trends in the Rio Grande based on the assays that we looked at. So the rare low cultural assays prior to 6,000, and then this really steep, almost straight up incline of radiocarbon assays right at 6,000. I believe that's clearly an example of taphononic bias. It's not a present, there's cultural activity going on out there. I just think all the stuff that we probably could have dated with the current technology, it's just gone. And similarly, the large increase the last 1,500 years, I think that is, at least a part, is affected by the preservation, the better preservation, and some of the calibration curve is happening. So we're having kind of an over-representation of some of this. So what looks like you have maybe 3 different occupations in 100 years, you probably have one that's just in a bad spot on the radiocarbon curve. I do think, however, that the decrease in open air sites during these times, the 25 to 1,500, and then the 45 to 3,500, and then an increase in rock shelters, I do think that's cultural. I'm not quite sure what all was affecting going on at the time, but it's something that I want to pursue further. And these are testable questions that we can follow through on. And this is the distinction between, I want to make clear on, this is the distinction of the analytical approach versus the descriptive approach. So this leads us, like all good studies, they lead us to more questions. So, and then one thing, how am I doing on time, Jimmy? Good. So this just came out, like, I think it's the last issue of American Antiquity. And it's one of those, it's a really good article by David Hurst Thomas and colleagues. And it kind of, amongst the other things it was talking about, it kind of talked about, it compared all the radiocarbon data from rock shelters and open air sites against each other in 2 different basins in the same range. So they're basically, you have kind of like one valley and then another valley, but they're all kind of in the same general basin. This is, I'm sorry, forgot to mention, this is Western Nevada. So it's in the Great Basin of Western Nevada. I think you can see Reno on the map somewhere, not sure. Anyway, you kind of get an idea. So it's not quite apples to what we just talked about, but it is basically they're taking data that they've encountered throughout the Holocene and then did kind of a similar study to what I just talked about. During that, one of the things they discovered is throughout the Holocene that the groups moved back and forth between each of those valleys in response to climatic events. And they basically had the paleo environment data from the lakes and some of the springs in the area that they were able to get pollen in. So it was a really, really detailed kind of a study. But they're able to kind of compare the open air and then the rock shelter from each of those basins, and they could demonstrate just by the dates, the movement. So it's like a fluorescence of activity in one basin and then a decrease in the other. And then conditions for whatever reason locally got bad, and then they moved back. So it's back and forth. And then David Hurst Thomas and the gang they called those syncopations, which I'm not too happy about, or I'm not excited about, but I did want to mention it. It did have kind of a unique ring, I thought, to it. So it's like the inhabitants kind of adjusting to whatever they needed to do to survive. They just kind of moved over to where it was better and then continued. The interesting thing is they found that these syncopations ended at about that 2,000-year period. There was the same climatic events that were pointing out those mega droughts were hitting this area too. And then the assays and then evidence of cultural material or evidence of cultural activity dramatically decreased. And then they argue that they fled, moved out, possibly to the north to better climate. So always getting supplementary materials. We grabbed their dates, which is like 800 dates, I think, something like that. It was a lot. It was a lot of fun. It was like, hey, let's throw this in the hopper and see what happens. So we, the green is the regional Rio Grande dates, and the blue is their open air dates from their study. And then the pink background, that's their rock shelter dates. And dang if it doesn't fit pretty well to, I didn't overlay the Rio Grande rock shelter dates, but they look pretty good. I mean, there's fewer, but the spikes kind of follow that same Rio Grande trend. But the thing that kind of got me excited again is, oh, and also you'll notice the decrease in the hiatus zone. But now my attention is kind of focused over on this purple area because it's like, this is a new thing now. So I'm like following the spark shiny thing. This is so I'm kind of excited about this new thing. What's going on with all these open air sites, but a decrease in rock shelter dates? So, and they didn't, the authors of, David Hurst Thomas and the gang didn't quite have an answer for it either. But anyway, some follow on down the trail. See, follow that through a little bit. So there's too many people for me to thank adequately, but here are the big ones. A lot of them, I'm truly indebted to every one of these people. And then in particular, all of the researchers that have come before who have kind of carried that ball and we're just kind of picking it up and moving a little bit further along. All right, so hopefully you guys didn't get too bored and we're kind of excited with the talk. But I feel like I'm in a circle of trust here with you all since I know most of you. So thank you for indulging me and talking to you about something I've been workshopping for a long time and something I'm very excited about. I will be doing this talk, or at least the 15-minute version, at the TAS. And so you guys got both barrels. So you got hopefully the fun part of the long talk. But anyway, thank you for inviting me. Oh, also, if anyone has radiocarbon dates and you can and are interested in sharing, please let me know. I'm looking. I'm always looking for radiocarbon dates. So does anyone have any questions? Yes.
Are you aware of, did you already connect the P3K radiocarbon dates?
So what?
Some of the people that you were citing in the papers were involved in the P3K People 3000 radiocarbon database, which may overlap with the data that you got from CARD, but there may be things in there that might not.
I'll have to look. I know a lot of the David Hurst Thomas and I think two other authors of that latest one. They were on the 2022 American Antiquity, so they were part of that. I'll catch you before I go. I'm curious. I hadn't heard of that. Does anyone else have any questions? Yes, Alex.
There was a term I wanted to know in your background. What is the marine reservoir effect?
Oh boy. Okay. Yeah, I did. And I did think about dropping it because it's like, I just don't want to get into it. Basically, it's kind of the same thing as the atmospheric, the influence. So the terrestrial dates, they have kind of a known. So when they're being corrected, there's something you can kind of correct the assay to kind of correct it. Whereas the marine assays. So people who consume shellfish, or if you're dating something, something that ate shellfish, there's a chance that that can't be corrected unless it's a marine. So you have to have kind of a local marine reservoir. Does that make sense? I know I'm skipping over, but basically I try and avoid it because it's just a pain. It's like there's always that doubt, is like, does this need to be corrected? Unless it's verifiably like a shell midden or something, you're gonna have to do it, especially working on the coast. It's a thing. And that's one of the reasons that, and there's only like 9 dates for Willisey and Cameron. It's like I just didn't want to deal with it. It's just like it's just a risk. But that's a good one. That's in Emily's thesis. She does a really good description, better than I can for sure. Yeah, Jimmy.
All right, on Zoom, a lot of accolades, excellent talk, thank you, clappy hands. But a question for Bill Purdue, do you have any indication of the size of the population variations during the periods?
No.
No.
You can't. People have tried and still will continue to try doing it. It's a bit too far, I think, to kind of do. I mean, the sampling bias, you get kind of the idea of like, we could probably do an estimation, but it would be, it would be. I don't think I'm not saying it's not worth doing. I just didn't want to take that on. But there are those that have done it. Any other questions? Yes.
When you showed us the graphs, and you had those two purple circles, when you were like, I didn't notice it until like recently.
Yeah.
What's your next course of action? What are you gonna look into for that?
Well, I'll talk to people who are smarter than me. So the Southwest Texas gang, talked to Charles Koenig and Steve Black and all my old friends. And then, because I mean, they've forgotten more about that region than I'll ever know. So basically, I just need to kind of say, hey, is this a thing? And if you know about it, where can I go and look into a little bit? So that's usually where I start, is I talk to people who are smarter than me, some of those friends and mentors I was telling you about. That's always a good start. And then kind of do kind of like a dive into, I usually look into some of those researchers that I can't inquire about, but I can read some of the research that they've done, like Mike Quigg. He's not around to ask, but he did a lot of incredible work in that region. So he's wanting to kind of like actually look at some of the other stuff he did, except for, get past the dates and kind of look at what he was writing and what he was researching. So that's usually where I start. Yes, Steve.
You mentioned that a lot of deposition over the time was pretty much constant.
At the 462?
Yeah.
Yeah, at 462, yeah. It was slow but constant.
Was it fluvial or?
It was alluvium. Yeah. Well, there's a little bit of colluvium coming in. The valley was a little over a mile wide, but there was Arroyo Los Olmos, and then there was like another tributary just 100 yards up. So that site was getting a lot of alluvium throughout the Holocene. And of course, that drainage kind of moved a little bit through the Holocene, lateral and left to right. But the valley margins are close. And in fact, on the eastern edge of that site, you could see some contribution of gravels coming from the uplands, but it's almost all alluvium.
Did the type of deposition really didn't matter?
The what?
The
Say that?
type of deposition didn't really matter. Study.
It does. I did calculate some sedimentation rates, but for the purposes of this talk, it was stratified enough to kind of not mix some of these dates, which is the key thing on that site. No, yeah, sorry. Hopefully that answered your question.
It did.
Anybody else?
No further than Zoom.
That's it. All right. Well, thank you guys for allowing me to play with you for a little bit. Thank you. Well, if you think of anything, there's my email, and happy to come back anytime. Hopefully I'll come back and actually watch. I mean, I am a member. I don't get to come up here too often. So anyway, thank you all.
And thank you for that talk. My favorite ones are the ones where you kind of end up with more questions than answers.
Yeah.
Honestly. Those are always the best, so I hope more comes out of it. If I.
Stay tuned.
2 cents theory, I'd assume. It's probably cultural, I would guess. It's probably just a more broader trend of maybe that cyclical aridity changes, maybe.
Yeah.
But you need environmental data and cultural data, et cetera, et cetera. So, with that, are we done? We're still sharing or not sharing? With that, I think we will move to closing the meeting. I do just wanna reiterate a couple things. Again, Tam, lots of events, so you guys can show up to Bear Prairie or Pinch Pot Kids this month or Dent Dig It, or some museum. Please join us in a Tam or 2 event over the next couple months. And also remember, next month, when Dr. Boulanger comes to talk, it will not be on Thursday next month. Our meeting will be on Wednesday. So I'll try to remind you guys of that, but just this time only, hopefully. Again, thank you, Tim, for being here. It was
My pleasure.
lovely. We really look forward to having those geoarchaeology. We love that stuff. Anyways, thank you everyone for being here tonight. Thank you for those who joined online tonight. I hope to see you guys next month, Wednesday the 8th.
Second.